Hello, I would like to talk about event loop in JavaScript. Event loop is how JavaScript handles the asynchronous. It isn't exposed to us directly, but instead we still understand it. We still need to understand it in order to write better JavaScript code. Before we dive into event loops, we need to understand key concepts like single thread, call stack, and asynchronously, and lastly promised and callbacks. JavaScript is a single-threaded language. What that means is that JavaScript cannot do multiple things at once. It cannot execute two statements at the same given time. It needs to execute it top to bottom, one by one. So to do that, we have a call stack. JavaScript has one single call stack, so they are added one after the other, depending on call order. So we are defining here two functions, actually three functions, and then we execute the first one. How call stack executes that is, it first defines all of this, and then it executes first function, which is here. It's console logged first, and then it executes third. What that means that there's a bottom of the call stack first function, and top of that a new function is added called third, which is this one. And then once it finishes executing third, it will zoom out of third and it will return to first, and then it also zoom out of first, and then it goes to the next function call, which is second. Once this is done, it will finish execution. We can also visualize it thinking that a call stack is an array-like thing. We can visualize it like this. First, the start call stack is empty, then first function is inserted, then third function is inserted, and we remove both of the functions, and then call stack is empty. Let's see some examples. JS2 and JS3. We can execute it. First is printed, then third, and lastly second, as expected. This is an example of call stack. And we can check the 3. Yeah, this is also recursive example of call stack. Let's try it out. As you see, it starts as 0, and then it keeps adding recursive itself, function recursive itself, until end condition is met, and then it stops. Asynchronously can be explained with the following analogy. Jane Doe decides to boil some water, and Jane thinks that watching the water boil isn't very fun. She decides to check her Twitter feed. She starts scrolling her feed. After some time, the water starts boiling. She turns off the stove, but she doesn't stop scrolling right after water is ready. Instead, she keeps scrolling until she hits the bottom of her Twitter feed. Once she reaches the bottom of her feed, then she decides to use the boiled water. If we match it with actual story, Jane is equal to JavaScript, water is asynchronous function, Twitter feed, rest of the functions that is in the call stack, turning off stove, async function is in the queue and ready to be executed. She is reaching bottom of her feed, bottom of her Twitter feed, call stack is empty. Jane uses water, and call stack in the function in the queue is being add it to the call stack and then execute it. We can look at the JavaScript 1 example. Let's add it 2 seconds for now and execute it. Okay, we didn't save it. First, she starts in boiling water, and then she reads her Twitter feed, and lastly, boiled water is returned. You might think that she has to wait 2 seconds, so it's not a real example, but let's reduce it to the 0 seconds to see she still has to wait until call stack is ready. Wait time is 0 now. You might expect it to work right after this, the first tweet, using the water after the first tweet, but she doesn't. She has to wait until all of it is done, because call stack has to be empty before executing rest. As you see, starts boiling water and Twitter feed, and lastly using boiled water. It's still added to the end of the call stack. Event loop is handled by promises and callbacks. So promises are a recently added feature of JavaScript, and if we check the example, this is basically the syntax for promise. This is where we return the promise, which takes a callback. First parameter is resolve and second one reject. This is just dummy example of like real world network request. This is checking the success, and once time's out it will fail. And let's execute it. It resolved. Let's also make sure that it fails. The function timed out. There's also another way of handling asynchronous callbacks in JavaScript with asynchronous functions, even more recent feature of JavaScript, and makes handling asynchronicity easier than promises. Okay, these are my fake network requests, and this is how we handle the asynchronicity with promises, and this is how we handle asynchronicity with asynchronous functions. As you see, we have a new keyword, await and async. This is fake network request. We don't need another then to use the data. It's just the raw data. And we might also need return some promise, and then return data may also be a promise. To handle that, we just append another await to the end of the after this statement. And this is how we handle the complex promise with promises. This is kinda more nesting and more code, and kinda this is easier to read, as you may realize. Let's execute it. End of data, promise, async, complex promise. They do the same thing, but it's kinda easier to read. There's also another tool which makes understanding callbacks real easy. So this is our call stack. Call stack is empty, or it's not. Actually it's empty, but first event is handled here, being ready, water is boiling, and then it's added to the event queue, and once it's ready, added to the call stack to execute. Reload the page to re-register the event. Okay. It's being ready in the web API and then added to the queue and executed in the call stack. Let's add more. As you see, first added to the web API, once it's ready, added to the event queue, and then added to the call stack to execute. Remember, if call stack is not, if it's not empty, it will not execute until it's empty. It will wait in the event queue. This is how event loop works in JavaScript.